Hi everyone! Welcome again to my channel, Math is Fun channel. Again, this channel is an educational channel to help you understand your lessons in mathematics. And this channel is intended to those who are doing the online classes out there and also those who are answering their module. This will help you develop your lessons in mathematics. And aside from that, this will also improve your performance in mathematics. So please do not forget to share this channel to your friends out there, especially those who are struggling in mathematics. This is a big help for them to, again, as what I have said, to develop their performance in mathematics. That is a very nice advocacy in life to ensure and to share your learnings and helping the people to learn mathematics. And with that, you will be blessed. Okay, so please do not forget to subscribe my channel and please do watch and support my channel. And of course, do not forget to put some comment if you have some comments about what you have learned about this in this video discussion. So that is sounds interesting, right? Yes, that sounds interesting rather. So by the way, Merry Christmas, everyone. Christmas is approaching. So that's why I'm wearing this hat of Santa so that you will feel the essence and you will feel the Christmas season. So again, so much for that. Let's now proceed to our discussion for today's video. So now our discussion will be actually welcome to the world of mathematics in modern world rather. So our discussion for today is about, again, it's part of mathematics in the modern world. So those who are having this subject, this is a very helpful lesson for those who are taking the grade 11 or 12 or especially students who have this subject or course, mathematics in the modern world. So our objectives for today's video discussion, of course, we're going to identify patterns in nature. Sorry, please bear with the noise outside because I'm doing this video discussion in daytime. So there are a lot of, some sounds or music backgrounds coming from the outside world who are joining with us today. So now going back to the objectives that I mentioned. So we are going to identify patterns in nature and regularities. Another thing that we're going to talk about, or our objectives rather, one of the objectives for today's video discussion is to articulate the importance of mathematics in one's life. And of course, to argue about the nature of mathematics, what is, how it is expressed, represented, and used. And of course, we're going to express appreciation for mathematics as a human endeavor. So these are the objectives that we will guide us in this video discussion. So to start with the topic, let's start with talking about the nature of mathematics. So what is the nature of mathematics? So I want you to think about it. So the nature of mathematics, it underscores the exploration of patterns in nature and the environment. Since math exists, or it is also what we call that mathematics is also a branch of science that deals with the patterns and the nature of shapes and also the figures. So that's why one of its nature of mathematics, it explores. Again, it explores the patterns in nature and the environment. That's why it says there, underscores the exploration of patterns in nature and the environment. Next is it deals with ideas translated to objects and concepts created by humans. And of course, one of its natures is it is used in technology, business, medicine, natural and data sciences, machine learning, and construction. And it helps organize patterns and regularities in the world. And of course, it distinguishes expressions from sentences. And lastly, it discusses the conventions in the mathematical language. In short, these will describe the nature of mathematics. And as you observe in general, we can say that one of the nature of mathematics, it will help us explore, it explores the patterns of nature, since it studies the shapes and figures of a certain object and also the environment. That is one of the natures of mathematics. We will talk more about this one as we go over with our discussion. So now, what is mathematics? How do we define mathematics? So in other definition, we define mathematics as the abstract science of number, quantity, and space. Mathematics may be studied in its own right, or shall I say the pure mathematics, or as it is applied to other disciplines such as physics and engineering, which refer to applied mathematics. In short, mathematics are classified into pure math and applied math. So please do not forget about the two types of mathematics or two branches of mathematics. We have the pure math and applied math. Another thing also to define mathematics, it is the study of such topics as quantity, structure, space, and change. And of course, in another context, it is defined as the science that deals with the logic of shape, quantity, and arrangement. And it is, in a simple definition, it is the study of numbers, shapes, and patterns. Okay? And of course, another thing also to define it so that it will be easier for us and develop the concept about the definition of mathematics, we can define it as the building block for everything in our daily lives, including mobile devices, architecture or the ancient and modern, both ancient and modern rather, art, money, engineering, and even sports. And of course, I want you to think about the answer rather of this question. As you can see, how important is mathematics in the modern world? I want you to think about that one. I know that some of you have different idea about the importance of mathematics in the modern world, especially nowadays. We are dealing with the pandemic. Okay? How is mathematics important in the midst of pandemic or in this modern world? Okay, math is incredibly important in our lives. We all know that because when we eat, we apply math. When we cook, we apply math. When we have this issues in life in these trying times, we need math. Correct? Knowing the active cases, the vaccines, and all. Everything is part of mathematics. So it is really true that math is incredibly important in our lives. And of course, without realizing it, we use mathematical concepts as well as the skills we learn from doing math problems every day. The laws of mathematics govern everything around us. And without a good understanding of them, one can encounter significant difficulties in life. As one of the maxim, it reminds me of about once there is a proponent or a mathematician once said that the essence of mathematics is not to make simple things complicated, but to make complicated things simple. That is really true. And aside from that, those who are not appreciating mathematics, they don't even know how heavy is life our life is rather. So that's one of the sayings that will support in this statement, that it says that one can encounter significant difficulties in life without a good understanding of mathematics. That's really true. If you don't know something about mathematics, you don't understand, you don't appreciate why you are learning these, then it will be difficult for you to apply it in a real life. And without our consciousness, we are already doing or applying mathematics in our life. So that's it. Patterns in nature and the regularities in the world. So patterns and counting are correlative. So they are interrelated to each other. The patterns and counting. Why? Because patterns involve numbers or counting. Counting involves or it has patterns. Correct? That's why patterns and counting are correlative. When we say correlative, or yeah, they are related to each other. So another thing also, counting happens when there is pattern. So as I have said a while ago, in counting there is a pattern. And when there is counting, there is logic. Yes, pattern in nature goes with logic or logical setup. And of course, patterns can be sequential, spatial, temporal, and even linguistic. And of course, examples of patterns in the world, as you can see, the counting numbers. The counting numbers are examples of patterns. Another, or even in odd numbers, it has patterns, correct? Or it involves patterns there. And of course, the sequence of the dates in the calendar, such as 1 to 30 being used month after month, there is a pattern in it. And of course, the 7 days in a week has a pattern also. And of course, the 12 months has patterns. And of course, the regular holidays, our favorite pattern, correct? Regular holidays where no classes, no class rather, and no work. So regular holidays also part of patterns. There is a pattern in regular holidays. And of course, these are celebrated in the same sequence every year, correct? Regular holidays are celebrated every year. With this phenomena, it will create a repetition of names or events called regularity. So if it occurs every year, yeah, or it happens regularly, then it talks about, or it is something related to the term regularity. We will define that one later. Okay, now let's talk about the definition of terms, the one that we have mentioned a while ago, words that we mentioned rather a while ago in the previous slides. Then we will now define it in standard definition. So when we say regularity class, it is the fact that the same thing always happens in the same circumstances. As I have mentioned a while ago, when you have holidays, it will be repetitively um, occur or will occur, correct? It will occur or happen every year. So that shows regularity. So again, regularity is the fact that the same thing always happens in the same circumstances. Another thing also for the definition of terms that I want you to remember is the word pattern. It is discernible regularity in the world or in a man-made design. So the elements of a pattern repeat in a predictable manner. So when we talk about pattern, it is part of the nature of mathematics, as I have mentioned a while ago. Next is patterns in nature. These are visible regularities of form found in the natural world. And the natural patterns include symmetries, threes, spirals, meanders, waves, foams, tessellations, cracks and stripes. So geometric pattern, very familiar with us because in mathematics there's always geometry because it studies the shapes and figures. So geometric pattern is a kind of pattern formed of geometric shapes and typically repeated like a wall paper design. And of course, regularity in the world, it states that the fact that the same thing always happens in the same circumstances. So according to the person, this one, sorry, for a while. So according to Ian Stewart in 1995, we live in a universe of patterns. Every night, the stars move in circles across the sky. The seasons cycle at yearly intervals. No two snowflakes are ever exactly the same, correct? But they all have six-fold symmetry. Tigers and zebras are covered in patterns of stripes. Leopards and hyenas are covered in patterns of spots. So it's really true that we live in a universe of patterns. I want you to close your eyes and try to imagine about the world or the things that surrounds you. Okay? You will realize that there is really a pattern. Try to be observant in everything that you have in this world, or even the things, both living and non-living things, they consist of pattern. That's why Ian Stewart is right. We live in a universe of patterns. Our solar system has patterns. Our life has patterns. Our daily chores have patterns rather. Even the coronavirus, our pandemic, the pandemic has a pattern. The viruses has pattern. The vaccines, they have patterns. So everything in this world, or all, or the universe rather, it has or full of patterns. That's why we live in a universe of patterns. So I want you to realize about that one. Another thing is human mind and culture have developed a formal system of thought recognizing, classifying, and exploiting patterns. We call it mathematics. By using mathematics to organize and systematize our ideas about patterns, we have discovered a great secret. Nature's patterns are not just there to be admired. Okay? All you can see in the nature's patterns, they are not intended only for beautification, for us to be admired, to admire them. There is a purpose in it, in every patterns that we have, okay, in the nature, in our nature rather. So they are vital clues to the rules that govern natural processes. So some examples of patterns in nature. Let's start with this, symmetry. I mentioned symmetry as part of patterns in nature. It means that agreement in dimension, due proportion, and arrangement. So in other form or in other definition, it is, or in language or in the context of language, it refers to a sense of harmonious and beautiful proportion and balance. And of course, in mathematics, when we say symmetry, it means an object is invariant to any of various transformations, including reflection, rotation, or scaling. So this is an example of symmetry. As you can see, the tree on the left side of the screen, it shows symmetric. So they are equal. Reflection. The left side of the tree is a reflection of its right side. So that's why, because they are symmetric. Another thing also that is that has shown there is the asymmetric. Asymmetric means they are not symmetric. As you can see, the difference between symmetric and asymmetric, symmetric, it's equal. They divide it equally. But for symmetric, they are not, or the left side is not a reflection of the right side of its image. Another illustration to show symmetry or symmetric objects. So you can see for the triangle and also for the below the triangle. So these represent symmetric, and the right side shows or represent asymmetry or asymmetric. So I hope you will be able to grasp and get the concept about symmetric and asymmetric. So another example for patterns in nature, spiral. It means a curve which emerges from a point moving farther away as it revolves around the point. It is a curved pattern that focuses on a center point in a series of circular shapes that revolve around it. Examples of spirals are pine cones, pineapples, hurricanes. So this is an example. An illustration shows a spiral, as you can see. So these are the different forms of spiral patterns in nature. And of course, the galaxy. This is an example. The third picture shows black holes. Black holes also shows spirals as patterns in nature. So another another patterns in nature that we have here is the meander. Meander is one of a series of regular sinus uh, curves, bends, loops, turns, or winding rather in the channel of a river, streaming, or other water course. In other contexts, a meander pattern includes a series of regular sinus curves, bends, loops, turns, or windings in the channel of a river, stream, or other water course. When a river shifts its channel within a valley, or it swings from side to side as it flows across its floodplain, it produces as meander pattern. Okay, so this is an example of a meander patterns. So as I have said, it is a sinuous curves. Yes, it bends, it has loops, it turns. It is windings or windings rather, or windings in the channel of a river or stream or other water course. Another example, this one shows a meander. Okay, so it's a sinuous curves. Another thing also, another example of patterns in nature is the wave. We all know that a wave is a disturbance that transfers energy through space or matter with little or no associated mass transport. The wave pattern is most often seen when looking at the ocean from above. Try to have you, I know you have experienced this one, trying to look at the sea. You can experience there, you can feel, and even you can describe the wave pattern. Again, the wave pattern is most often seen when looking at the ocean from above. However, you can also see wave pattern in nature, not only in the ocean that you can see waves, but also in the other part of nature when the wind blows through the grass. Okay, that is an example of a wave. Okay, another thing also that shows an example of a wave, and this one, the sand. Okay, the wave of the sand. So these are examples of a wave. Another examples of patterns in nature, aside from the wave, is a foam. A foam is a substance formed by trapping pockets of gas in a liquid or solid. It referred to as a mass of bubbles, but other types of foams can be seen within the patterns of certain animal species, such as the leopard, giraffe, and tortoises. So this is an example of a foam, as you can see. Yes, yeah, a group or a mass of bubbles, really, indeed. So that's how we define a foam. So a foam is part of the patterns in nature. So another thing also that will give us an example of patterns in nature is the word tessellation. A tessellation is a flat surface, is the tiling of plane using one or more geometric shapes called tiles with no overlaps and no gaps. In mathematics, we say tessellation, it can be generalized to higher dimensions and a variety of geometries. A periodic tiling has a repeating pattern, as you can see. That is an example of a tessellation. As you observe, it's a repetition, yes. A flat surface, yes. The tiling of plane, yes. And it uses more geometric shapes, called the tiles, yes. It has no, or there is no overlaps in it, yes, and no gaps. So another example for tessellation, as you can see, the shape of a, okay, 6 sides, right? Hexagon, it repeats several times. Okay, so another patterns in nature is fracture or crack, or fractures or cracks. So it is the separation of an object or material into two or more pieces under the action of stress. And another meaning for this about fracture or cracks, it is or are linear, sorry. We have visitors coming from the outside world, the sounds of the waves, announcement coming from the city. Let's just make it stop first before we continue. Okay, so now let's proceed. When we say fractures or cracks, these are linear openings that form in materials to relieve stress. When a material fails in all directions, it results in cracks. The patterns created reveal if the material is elastic or not. So this is an example of fractures or cracks. Okay, very easy to locate. Yes. So another example of patterns in nature. is or are stripes. So stripes means are made by a series of bands or strips, often of the same width and color along the length. A stripe is a line rather or band that differs in color or tone from an adjacent area. So that is an example of stripes can be seen in the skin of a zebra and of course for the leopard. So these are examples of stripes. And lastly, fractal, not lastly, second to the last, fractal is a never-ending pattern. Fractals are infinitely complex patterns that are self-similar across different scales. They are created by repeating a simple process over and over in an ongoing feedback loop. So this is an example of a fractal, as you can see. Yes, there is a self-similarity across the different sizes and scales of a given object. That is one of the characteristics of a fractal in nature. And lastly, the affine transformation is part of the patterns in nature. It is the processes of rotation, reflection, and scaling. It is the process of reflection, rotation, and scaling, which I said a while ago, are seen to be operating in nature to generate biological forms. Geometry and symmetry, rather, are basic geometrical figures that can be found in nature, such as the hexagonal arrangement of snowflakes. So this is an example of an affine transformation. Yeah, it is the processes of rotation, reflection, and scale. Look at, they're just the same, similar, all patterns. And this is another example for a fine transformation. So now there are other pictures show patterns and regularities in nature. So some of it, yes, the sunflowers, this object, the flower, okay, the leopards. And of course, this one familiar with this plant? Yes. And also the bubbles. So these are the different patterns and regularities in nature. So I want you to remember that one. So we will stop in here. So I hope you are learning so far in the different patterns in natures and regularities. And of course, I hope you have a little background or you get something about the concept of mathematics and also mathematics in the modern world. So of course, it's very important to know these patterns and also know the concept of mathematics and also mathematics in the modern world so that it will be easier for us to understand and appreciate everything or every concept in mathematics. So if you have some question, you can just write it in the comment section. And if you, I want to read your comments or the things that you have learned in this video discussion. So thank you for listening until the end of this or part of this video discussion. So with that, we call it a day. Always remember, math is fun. Thank you for listening. Have a good day. And please don't forget to subscribe my channel and share this one to your friends. Merry Christmas, everyone.